Welcome back to session number 4. So in the previous session, we closed with some ideas about lean production. So lean production combines the advantages of craft and mass production, right? So mass production, we defined that they set a goal of just good enough, acceptable number of defects, a maximum acceptable level of inventories, a narrow range of standardized products. Uh, Compared to in the lean production, we are looking for more perfection, zero defects, zero inventories, and endless product variety, right? So when we talk about endless product variety, that is where we are looking for more mass customization, right? And one of the main ideas is to reduce the setup time. So we reduce it from say a day to 3 minutes. And I will relate when we talk about the Little's law that what are the advantages of reducing the setup time. So one advantage which explicitly comes in is you can actually, because you want to produce more variety, but now the batches are much smaller, right? In fact, if you recall, we talked about that single minute exchange of die, right? So it means that you are still not to a continuous production, but you actually are closer to it, right? So you keep on changing the dies and you keep on um, uh, bringing more and more variety, right? So, so when we talk about small batches, in fact, I'll show you, as I mentioned, that it will reduce the amount of inventory, right? So, with this, I'll go to the next one, right? So, if you just look at the numbers, right? So, these numbers are for two different plants, and I've taken it from this book, WOMAC. The title is "The Machine That Changed the World." And it's a extremely good description of or maybe a comparison of the lean or the mass customization to mass production systems, right? So in fact we sometimes call it the Ford production system or a Toyota production system. It actually compares both of them and you can actually see the numbers, right? So you look at the inventory numbers, it says 2 weeks, it is just 2 hours, right? So these numbers were significantly lower uh, in the Toyota's case, right? So if you look at a Toyota plant, the numbers are much smaller compared to what you actually see at the GM plant, right? So this gives you some idea about what are the benefits of reducing the inventory. So it's not about zero inventory. I think the idea should be I need the right amount of inventory in my system, and my process should be synchronized in such a manner that that inventory should always be available, right? So, when we go from mass production to mass customization, something also changed is the organization architecture or structure, right? So, if you see this, so this outer boundary, the gray boundary, is actually for a Ford setting in 1930s. So it means that the organization was heavily vertically integrated, right? So it means that they were virtually producing each and everything, right? So you can actually see the tires would be produced by Ford itself, the seats, everything. And if you take it to a typical Toyota plant, so some of these things they still do make, but some of these things are actually getting outsourced, right? So I've taken it this from book by David Krebs. It talks about vertical integration to supply chains, right? So you actually start seeing the emergence of supply chains in the automotive industry when some of these things are getting outsourced, right? And the main idea here is that when we talk about the vertical integration, in fact, this problem is not new. Um, this may start in 1930s, right? So maybe the academic research started in 1930s that why some of these companies are vertically integrated. And the concept which comes out is the transaction cost, right? And which includes the agency cost. So when I say agency cost, it is actually the cost of maybe you can at a very crude level you can actually say that it's the cost of maintaining a supplier, right? So I should ensure that the supplier is actually doing what is actually in my benefit. So this becomes a problem of incentive alignment. So all these costs are cost agency cost, right? So uh, let me emphasize that maybe in 1930s the technology was not available to actually put a proper monitoring at the supplier end, right? So supplier may do what is in their benefit, right? Compared to the benefit of maybe the supply chain or the OEMs, right? And as the technology improves, you can actually see that these transaction cost, I can call it the cost of say monitoring someone, actually comes down, right? So with the more advent of say communications networks, communication systems, observability and verifiability, I'll define what they mean. The that improves, right? And in fact, Oliver Williamson actually shared the Nobel Prize for defining or distinguishing different architecture of organizations, right? So, in fact, one of the classical example of incentive misalignment comes in the form of a law of nature, which in supply chains we call as the bullwhip effect. So the word actually comes because if you might have seen the bullwhip, so a small variation, a small fluctuation in my hand, the other end of the whip, the fluctuation may be very high, right? So you can actually see that in this case there are three uh, agents in a supply chain. There is a manufacturer, there is a wholesaler, there is a retailer, and the retailer is actually closer to the market, right? You can actually see that, right? Now, what happens is the retailer actually gets a better information about the demand from the market because being closer to the market, and then that information actually flows in the upstream direction. So retailer gets that information goes to the wholesaler, and then wholesaler gives that information to the manufacturer, right? Now, something which is evident from this figure is that here the fluctuations may be okay, but the fluctuations are getting inflated as you go upstream in the supply chain, right? So this is something which has been observed in multiple supply chain settings, right? So the fluctuation or the variability as you go upstream in the supply chain, that actually keeps on increasing, right? So the first evidence, maybe the first documented evidence, came from Procter and Gamble in 1919, right? So it's maybe more than a 100-year-old problem, right? And the reasons could be multiple. In fact, one reason could be the delay of pass of that information, right? So retailer may get that information, but by the time the information actually reaches upstream, right? The production planning, everything has been done at the wholesaler demand, correct? So it means that there is some kind of asynchronous production and the demand, right? So that will create some kind of fluctuations, but that's not enough. I think one of the critical things which could be is in the form of because these are all firms, right? And they look for their own benefit or profit, right? So they optimize for their benefit, correct? So if it is in the favor of the retailer to actually inflate the demand, they will actually do that. So it will be rational for them to actually do that, right? So this actually brings an idea in supply chains, what we call as double marginalization, which actually means that two firms, when they look for their own benefit, individually they gain, but collectively they lose, right? So in fact, this actually brings the problem of what we call as a supply chain miscoordination or uncoordination, right? It means that the retailer will be looking for his or her own benefit, wholesaler will also be doing the same thing, right? But collectively they actually lose, right? So a lot of the literature on supply chain contracting would actually be how you actually mitigate this problem of double marginalization. In fact, there would be a substantial literature on how you actually overcome this bullwhip effect. So technology could be one enabler which actually can reduce the impact of the bullwhip, right? So I'll talk about it, but just to give you an idea that there is a possibility of say vendor managed inventory, correct? Right? So in this case, in fact, in this case, the wholesaler will actually have a better information about what is actually happening in the market. So if you in fact see some of the ERP systems, they will actually be doing the same thing, right? So for time being, I think I'll not spend too much time on this, but the point here is that this how to mitigate this double marginalization. In fact, most of the supply chain contracting literature would talk about that, right? So if you want a reference for it, you can actually see a paper by Cashon published in 2003 on supply chain contracts, right? Now, what is the advantage of outsourcing something, right? So the first thing is when we look at a setting like this, the Ford system, you can easily see that they need expertise in virtually everything, whatever goes into an automobile, right? So they should be expert in seats, they should be expert in brakes, they should be expert in wheels, they should be expert in tires, right? So all these things should be available, all that knowledge should be available within the firm, right? Now, as the complexity of a product keeps on increasing, getting that expertise will not be that easy, correct? So, let me just rub this part, right? Correct. So, what it means is that when you outsource something, so there should be some benefits which comes in, right? So that could be in the form maybe of first is maybe that expertise availability. Other point which may be more explicit is the cost reduction in supply chains due to economies of scale and experience curves, right? So it means that when I'm outsourcing something, so I may not be the only person who is actually outsourcing. There would be maybe other firms also doing the same thing. Like there is a possibility that the same supplier will actually be providing the things to Ford as well as to Toyota, right? So you can actually see large volumes coming at the supplier end, and you already have seen the benefits of the increasing scales, right? So economies of scales comes into the picture, and what it will do, it will actually improve the cost, right? It will in fact reduce the cost. When I say improve, it will reduce the cost, correct? And the other thing which comes more again explicitly is the experience curve, because the supplier would actually be doing the same thing again and again and again. The cost keeps on decreasing, right? So the cost benefit actually comes when we outsource something, correct? So this is something, so the point here is we have to actually compare whether the transaction cost of outsourcing is actually higher than the cost reduction which comes because of this, right? So if I can monitor my supplier well, in that case, the cost reduction which comes because of economies of scale and experience curve, those things will actually dominate the transaction cost, correct? So you would see more and more things getting outsourced, right? So I think you are getting the sense of it, and the sense comes in the form of that advances in technology reduce the transaction cost, right? So there would be a lot of things which may have happened post 1950s, right? So you actually can see maybe the emergence of MRP and ERP systems, right? So certainly I'm not going to spend too much time on them. If you see a typical operations management or supply chain course, you would actually find these concepts, right? But the point here is they allow us to reduce the transaction cost of getting it from the supplier, right? One other thing which comes is the significant reduction in the logistic cost. In fact, this book by Mark Levinson talks about how the shipping container actually, so in fact, some people claim that shipping container itself was a big innovation, right? So maybe in the past 50 years. So this shipping container actually improved the trade and reduced the transaction cost and made the world smaller and the world economy bigger, right? So the transaction cost comes down. You can actually uh, trade maybe far distances, right? So supply chains start becoming more and more globally distributed, right? So even when these systems like MRP or ERP is there, the visibility in the production actually improves, right? We'll talk about that, correct? And one thing which comes is also maybe the lot of operations research model comes in, which start allowing us to optimize just not at a maybe an organizational level, maybe at the supply chain level, right? So a lot of these things have significantly reduced the transaction cost, and you start seeing the emergence of organizations maybe in this form, right? But the key question is what next? Can we improve this further, right? So one thing which could come is when I talked about the visibility, right? So you can think of a typical supply chain. I give you an example, right? So there is a lot of emphasis on the electric vehicles these days, right? So a significant amount of uh, um, cobalt is actually used in the production of lithium ion batteries. So battery may be the, when I say lithium ion, that is something which is the dominant chemistry for these electric vehicles, and a significant amount of cobalt goes into them, right? But most of the cobalt actually comes from the Democratic Republic of Congo, right? And the supply chains are highly opaque, right? So there is a lot of debate how we ensure that these supply chains are actually using the ethical sources, right? So we want to ensure that uh, there is no child labor involved in these, say, cobalt mining, right? Now, to ensure that thing, so as of now, I think the visibility is not much. The supply chains are highly opaque. Can we use technology to actually improve that visibility? Right? At that point, I think we are pointing towards something like the technology of blockchains, right? I'll talk about that. I think we will have ample discussion on blockchains, right? But the point here is, can blockchain improve the visibility and reduce this transaction cost? So when I say visibility, I'm looking at, can I observe what is actually happening at the supplier end, right? I extend this argument further. So these days we talk a lot of things about the Internet of Things. In fact, we are going to talk about significantly again in this course. When we talk about Internet of Things, many things will be based on the sensor, right? So you would have an embedded sensor, correct? Now, whether that will actually improve the visibility, right? Okay. So the point here is, can this technology, or maybe the emerging technology, or maybe I will use more fancy word, disruptive technology, will it actually improve the transaction cost, right? So in which direction we are actually heading, correct? But my emphasis would still be on that I am moving towards from mass production to mass customization, right? The organization architecture is changing, correct? And you can actually see that we are moving from say fast, cheap, right? Uh, Better. So I think there are a lot of emphasis on quality also comes in, but at the same time we are also looking at diversity, right? So we are moving in the right direction, correct? So if you recall, I mentioned about the quality part, right? So we have faster, we have cheaper, we have better, and we have diverse also, right? But the question is always there: can we actually improve? Can we do better, right? So will there be a possibility of going for mass personalization, right? So I can produce something specific to that customer, correct? So instead of saying that I produce say Toyota car and 3 or 4 variants, I can actually customize it to the customer requirement, right? Correct. So is it possible to actually go to that extent, right? And moreover, I may be looking uh, for an organization which is not even integrated, vertically integrated to this extent, right? So I may be looking maybe just this, correct? So whatever I need should actually come maybe from outside, but can we extend that argument that whenever I demand something, it becomes available, right? So we are going to talk about the platforms, right? Correct. So I think that is where when we talk about can we redesign our supply chains. So instead of talking about supply chain, in fact, I'm now using maybe a word called platforms, right? So in fact, I think there is an HBR paper we'll briefly talk about as we go further into the course. The title itself is Pipelines to Platforms. So from supply chains to platforms, right? So the whole organization architecture, or significantly maybe for manufacturing, should completely move from that pipeline structure to platforms, correct? And what enables that is the technology like blockchain, the technology like the additive manufacturing, the technology like machine intelligence, right? Technology like IoT, right? So what the point here is that we are looking for more and more visibility, more and more tracing, right? If I can ensure what is actually happening upstream or downstream, the things will be much more transparent and you will actually see an emergence of a different manufacturing architecture altogether. I'm not talking about the product architecture, I'm talking about the organization architecture, right? So, yeah, so I think this is fine. Let me now start talking about different laws of manufacturing, right? So, the fundamental thing when we talk about any manufacturing organization, right? Uh, there would so at the core we always want to match the supply with demand, right? Independent of whether it's a typical service or in manufacturing, but there will always be some kind of what you call uncertainty or variability on the supply side. There will always be uncertainty or variability on the demand side, and we always want to match that supply with demand, right? And you want to do it in an environment. In this case, the environment could be the business environment. The environment could be the national environment, right? Even it could be anything. Just think of COVID scenario, right? Something which comes abruptly, right? Now, what I want is I want to match that available supply with demand. So you can think of maybe the demand for ventilators, right? Suddenly that thing has come, and there would be a ample supply constraints, right? You cannot get it from outside India. You have to do some local sourcing, right? But whatever you is available, you want to match it with the demand, whatever is coming in the say for ventilators, right? Now, so in this kind of an environment, you will always see lot of variability and uncertainty, right? So when I say variability, it means that the environment will not remain constant. It actually varies with time, and moreover that variation is unpredictable, right? So I cannot put a function to it. Even if I put a function, it will come with lot of errors, right? So there will always be some uncertainty and variability within that kind of an environment setting. I want to match the supply with demand. In fact, the bullwhip effect, what we have seen earlier, could be an example for it. You can actually see that there is so much of variability there, and that variability is actually increasing as we go upstream, right? So, let me make it more precise that I want to match demand with supply in an uncertain and variable environment. And let us say that variability and uncertainty is more of a rule rather than an exception, correct? Now, this becomes, in fact, in operations management, this is the objective. I want to match demand with supply. And how we define variation? Variation is the major deviation from the expected outcome, right? So you expect some outcome, and so that could be true even for demand, right? So I expect my demand to be high, but it turns out to be low, and that which I can measure, right? So variation is the major deviation from the expected outcome, right? Now, the interplay is always that I cannot remove this variation, I cannot remove this uncertainty. Maybe I can reduce it. I'll talk about that. But the point is, given this variability and uncertainty in the environment, how should I change my supply strategy? How should I uh, look at the demand, right? And how I do this matching, correct? Right. And so again, demand is more or less exogenous. You cannot control much on the demand side, right? But there is a possibility that you can always reduce the variability of the demand. We'll talk about that, right? Correct. But you believe me that these things will not be static at all. They will always be so much of variability and uncertainty. Correct. Right. Now, what actually matches this is this notion of what we call as buffers, right? Correct. So you can think of maybe I give you an analogy from a typical civil engineering setting, right? So you see, so we sometimes called as maybe a headwork or a barrage or a dam, right? Correct. So if you talk about maybe a runoff which comes during the rainy season, the monsoon, right? So it comes for a very short period, correct? Right. And but the demand of say water downstream will always be, there would be variation there also, right? But that will be more or less um, constant in a year. But the supply is highly variable, right? And it comes only for a very short period of time, right? So what we do, we normally need some kind of a buffer which actually becomes like a control structure in the form of a headwork or a dam, which stores the water, right? And which can be released maybe continuously to meet the demand maybe for around the year, right? Now what we are doing in this case, we are talking about maybe a highly uncertain variable environment, but the objective is still how you actually match the supply with demand, correct? And what is needed is some kind of a buffer, right? So when we look at a typical manufacturing setting, we see three kind of buffers. One is the inventory buffer, the second one is the capacity buffer, right? And third is the time buffer, right? And the point is these buffers are not cheap, they're expensive, right? So inventory is costly, the capacity is costly, and even the time is costly, right? So in the next session, I will continue with this idea of buffers, right? And I'll conclude these laws of manufacturing and the role these buffers play in matching these demand and supply in a typical manufacturing setting, right? So thank you.